the summer of 2015, reporter Andy Greenberg got behind the wheel of a Jeep Cherokee, then proceeded to drive onto Interstate 70 in St. Louis during rush hour. Miles away, well-known hackers Charlie Miller and Chris Valasek connected to the vehicle remotely and wirelessly disabled Andy's brakes. What happened next is documented in a video shot within the Cherokee as Andy realized what happened and safely pulled his Cherokee off the road. Andy knew something would happen, and he later told me he wasn't sure exactly what would happen. That video and the accompanying article electrified the automotive industry. I know, because my first day at Synopsys in November of 2015 was in Auburn Hills, Michigan, for a meeting of the OEM vendors and security professionals, a group known as the Featherstone Group that would later produce through SAE what is now recognized as ISO SAE 21434, that defines engineering requirements for cybersecurity risk management in the context of road vehicles. Although Fiat Chrysler recalled 1.4 million vehicles and suffered brand damage as a result, it turned out that the fault was within the Uconnect system, a communication system manufactured by Harman Kardon, a third-party supplier. We know this because there's strict accountability in the automotive industry. All the parts are registered, the supply chain is well documented, and they were able to trace it down to the specific part that failed. Not all industries are like the automotive industry. Much of the ICS world consists of components produced by third parties. For example, in the summer of 2024, water systems produced by an Israeli manufacturer were targeted by Iranian actors, the Cyber Avengers. The U.S. water districts that were affected were mostly small, rural systems, and they lacked the ability to vet their devices beforehand, let alone update them once a patch was issued. The risks posed by third-party devices within ICS have not been discussed enough, in my opinion. Well, in a moment, I'll talk to someone who is typically hired by the buyers of ICS equipment, such as utilities, to assess and mitigate supply chain risks, including working with the OEM to improve their security. This is the story about how ICS software lacks the strict liability standards found in industries like automotive manufacturing, and how this can lead to insecure products being exploited in the field. I'm Robert Vamosi. This is Error Code.
I am Alex Santos, Chief Executive Officer of Fortress Information Security. Fortress secures critical infrastructure supply chains from cyber threats.
When I think of critical infrastructure supply chains, I think of automotive, where you've got tiers 3, 2, 1, all building up to the OEM.
That's exactly right. Take, for instance, an F-18 fighter jet that was in the movie Top Gun Maverick. We're focused on looking at the individual components that comprise the systems aboard that airplane, much like you said, different tiers in an automobile. For example, we're looking to see if the communications are properly encrypted, that the mission systems are protected from spoofing and other vulnerabilities. So exactly as that's a great analogy, is the auto manufacturers. And the key is, as you said, tier 2, 3, 4, and 5 components.
So it's the suppliers that are further removed from the final product that needs to be focused upon.
Yeah, I've been doing this now. I'm an entrepreneur, and I've done 3 companies in different industries, and I've been doing this one for 10 years. So I don't know that makes me a veteran in cybersecurity, but it makes me at least a middle-aged. So my experience has been that it's just like when we grew up as kids. You know, our parents used to say that, you know, the bad guys are going to eventually get in and they're going to try to find the weakest link. And I feel like it's the same thing here. The tier 1 is kind of obvious, right? Going back to that F-18, it's Boeing. But tiers 3, 4, and 5, Boeing may not even know who they are. And I think the adversary knows that because it's hard to get visibility that deep into the supply chain, that it's the weak link. right? It's the easiest way for them to burrow into the supply chain. There's been a lot of money spent. There's been a lot of people that have entered our profession in the last 10 years. And I think some of the more obvious attack vectors have been the defense of those attack vectors, or to those attack vectors, has been increased significantly. So I think the adversary's constantly looking for the weak link. And I think that's why they're drawn. I think that's really the challenge for the defenders of supply chain, because it's such a complicated, vast field. It really drives up the cost and complexity. And that's what makes it not as well defended, which makes it attractive to the adversary.
Related to supply chains, I often think of software bill of materials, or SBOMs. These are ingredient lists. They show what open software is used, for example, and what versions they are, even if they're vulnerable to known CVEs. There are also hardware bill of materials and even AI bill of materials as well.
H-bombs, S-bombs, AI bombs, any kind of component where an adversary can expose the weak link, because it takes time, effort, and complexity to look into those supply chains. Because, one thing that's fundamental about SBOMs and about looking at the components is the construct of the business relationship between a supplier and the customer. In the United States, usually a manufacturer of software doesn't have any sort of duty of care to its customer, other than to assure its customer that any documentation it provides is accurate, which is, I'm trying to be sarcastic there because that's really not much. So manufacturers don't owe, unlike the automobile industry, which you brought up, right? If you sell a consumer a car and that car gets hit from behind by another car and the gas tank catches fire, that manufacturer is liable. And I believe, if my bar exam, it's been a while, but I think it's what's called strict liability, which means it's the burden of proof is on the defendant to prove that they didn't have. So Ford would have to prove that they built a great gas tank. The plaintiff doesn't have to prove that Ford built a defective gas tank. That's the way the law is set up. Why? To protect consumers so that the cars don't blow up. Well, software, unlike a car, even though they're both products, there is no liability placed on the manufacturer. So what happens is it's buyer beware. And the reason we need S-bombs and H-bombs and AI bombs is because the manufacturers of these products don't make quality products. They make products full of vulnerabilities. So it's actually shifts the burden on the consumer to have to go and find the problems and fix the problems. So S-bombs is one of many manifestations of that dynamic, of that difference between software and automobiles.
So are there testing requirements for OEMs as they're incorporating Tier 3, Tier 4 material into their products, all the way to the final product?
I'm not aware of any testing requirements that apply broadly, particularly for cybersecurity. I assume there are testing requirements in place, but they're probably more for operational use, not so much for security. And so that's, again, leaves the consumer, the buyer of the software or the product, in the predicament of having to secure it, even though they don't have any control over the supply chain.
So where does someone like Alex come in? He's not necessarily working with the lower tier vendors directly.
It would be better if we were hired by the OEM. We're actually hired by the customer. So imagine if when you buy a Ford, you had to inspect whether the gas tank was susceptible to catching fire. We're hired by the buyer of complicated OT equipment. And our job is to identify the risks and help the customer, and oftentimes with the OEM, devise ways to use and install and use, I should say, the product in a cyber safe way.
So if I was an energy utility of some kind and I wanted to purchase, say, a Schneider Electric product, Alex, he would be the go-between. He would evaluate the product and he would report back to the utility and then work with the OEM to address any issues that might have come up.
Exactly correct. And as part of that interaction, as part of that relationship, as you called it, which I think is a good term, by the way, as part of that relationship, we would be working with Schneider to identify the second, third, fourth, and fifth tier suppliers.
So I know with automotive, they can trace it down to a tiny component. They know exactly who made it, on what day, and where it is in the world. I'm wondering, with ICS software, is this the same?
Why do you think the automotive supply chain tracks it so closely? Because of recalls, maybe? Remember, recalls, I think, assume that the manufacturer has a legal duty to the consumer. In software, there is no legal duty to the consumer. So there is no tracking. If there was a recall, it would be practically impossible to well, let me say it this way. The level of tracking, lot tracking, and traceability in autos far exceeds by orders of magnitude what's done in software.
So earlier, Alex brought up a fighter jet. And I would think that there would be some sort of rigor there because, well, it's an expensive piece of military equipment.
Yeah, the fighter jets are built to requirements. And, those requirements, it's been reported that those requirements don't include extensive cybersecurity, supply chain cybersecurity risk management. That's where we come in. But no, that's how we got into the DoD, is we discovered that didn't exist, and it kind of surprised us. Although it didn't surprise us, but that's what made it attractive to us, is because we had done the same thing in the utility business where there was no vetting, and we came in and solved it for the industry. And so we thought we might take a crack at doing the same thing in DoD.
So going beyond fighter jets, what other industries has he found traction in?
I think what I've personally learned is critical infrastructure as a whole has the same problems. Critical infrastructure, the way I think about it is, our citizens in our country depend on this infrastructure to live. Water, power, transportation, telecommunications, financial services. And these are private entities that are for profit. But because we're living in an age where cyber is part of war, now our critical infrastructure is susceptible to attack and is a target of our adversaries. But it's operated by companies in the private sector who have incentive to make money, to maximize profits. That's a conflict of interest between spending money on cyber and maximizing shareholder returns. Every dollar I spend on cyber takes money away from shareholders. So why do companies spend money on cyber? Well, first, regulations, because they have to, particularly if there are fines. There's plenty of examples where, in the absence of fines, companies don't spend money to be compliant with regulations. But also, where there's a clear business case for cyber. Like, for example, I think the CrowdStrike event, which wasn't a cyber attack, shows what can happen in a cyber attack when your entire IT infrastructure goes down for a period of time. It costs real dollars and cents to your bottom line. So I think that's sort of the return on investment that for-profit companies look at when they spend money on cyber. Where it runs into a problem is for drastic events that have never happened before, like a Chinese attack on our infrastructure has never happened before. And so it's hard for for-profit entities to justify spending money on something like that. So we at Fortress have decided to make it our mission to secure critical infrastructure and to devise ways to do it at a low cost by teaming up with the government in private-public partnerships to drive down the cost and try to make the best of a bad situation.
So now it seems like we're talking about the typhoons. The idea that a foreign nation can get into a supply chain and permeate critical infrastructure being used in, say, military bases in Guam or in a U.S. city.
Correct. Because I guess the part I left out was critical infrastructure operators depend on equipment that they buy from vendors, which is all ICS equipment. Going back to the ICS topic, mostly ICS equipment.
So there are 16 critical infrastructures. Is Alex saying that he's playing in all of them?
Today, we focus on energy and DoD. We're expanding into several of the others: critical manufacturing, transportation, telecom is where we're expanding into.
Are the leaders in those industries, are they pushing back? Are they saying we can't possibly mitigate all of this at once?
Again, I think this comes down to accountability. So in the auto industry, the manufacturers are accountable to the consumer. Here, the telecom companies are not accountable for the cybersecurity, right? The critical infrastructure operators are not accountable necessarily. Like, the telecom providers didn't get sued over this. I mean, there haven't been any penalties. I think historically in our country, if it's a nation state attack, you're kind of off the hook because it's a nation state attack. It's a nation state attack, therefore I couldn't have done anything about it. Well, the problem with that is, whose job is it? Because the government isn't really taking ownership and accountability for dealing with those attacks. They've outsourced that to the private sector. I don't think that's correct, by the way, but that's what we've done. So if the private sector, if it then becomes the private sector's job, they have to be accountable for it. And so I think that those telecom providers should take accountability for it. But we have to recognize that there's a conflict of interest because these are for-profit companies. So, I think that, and I don't think anyone wants more regulation. So I think the government needs to do is, if they're not going to help critical infrastructure defend itself against sophisticated nation states, it needs to provide them an incentive to spend money and allocate resources to that task. I mean, you have to pick your poison, right? You either have to live with them not being accountable, or you have to regulate them, or you have to privatize them, which is probably the worst idea, or you have to give them an incentive to allocate resources to these low probability, high impact events.
So we haven't seen that type of attack. The fact that it's kind of just out there implies that it could, at some future point in time, happen. But I know that the energy grid is broken up such that you're not going to black out the entire United States in one fell swoop. That's just not possible. That's not how it works. Moving on, in terms of regulation, what about self-regulation like NERC or FERC? Is industry regulation better than government regulation?
I would say it's better than, yes, I would say yes, clearly.
They know the industry.
Because they know the industry. And I participated in these hearings, or hearings is the wrong word, these meetings. The industry, if we're talking about NERC, they have positive intent on these regulations. They're trying to solve the problem, and they're trying to do it in a way that works for the constituencies, the various stakeholders. So I think that's better than, the government in an ivory tower coming up with these regulations. I think TSA is an example of that, right? After Colonial Pipeline.
In May of 2021, ransomware struck the Colonial Pipeline, which runs along the eastern seaboard of the United States. In an abundance of caution, Colonial shut down the entire pipeline, not knowing whether the ransomware had impacted the OT side of the house or not. Only the IT side was affected. Because the pipeline runs across many states, the Transportation Safety Administration weighed in with guidance afterwards.
TSA issued a bunch of regulations that had everyone scratching their heads, and I haven't heard anyone say that those are being enforced, and maybe that's because they didn't get the buy-in of the regulated entities. Like leadership, one of the fundamentals of leadership is to, at least the way I like to lead, is to get the buy-in from the people that you're leading. So I agree that's a good thing, but it's not perfect. I think maybe it's because I'm a lawyer. I think that holding them accountable legally would be the optimal way.
So I wanted to ask Alex the type of stuff that he's seeing today and how he's going about evangelizing it.
What we're doing now with the Department of Defense is something that we did with the utility industry, and is really to work as a team, as an industry, because in both cases, energy and in defense, all the entities in those industries share the supply chain. So we like to say, share the risk, share the burden. So if you share the risk, share the burden. So we've, in utilities, for example, we've recruited 6 of the top 10 largest utilities to share information specifically risk information about their supply chain, and work hand in hand with each other and with the vendors to do more secure by design, create security patches for equipment that's in the field, work on upgrading legacy equipment in the field, because sometimes the software is out of support. So similarly, we've been able to convince the Department of Defense that is the most economic way forward, is to, if you share the risk, to share the burden. Because just like with energy, the Department of Defense has pretty much the same supply chain, right? We have 10 large primes or so, and we have they even have a common name called the Defense Industrial Base, right? The DIB. So we're working on similar apparatuses with the DoD, where if we look at a radio on an F-18, and that radio, and we checked it's properly encrypting voice communications, we don't have to check it again on the A-10 Warthog if it's the same radio, right? So we save time and money that way. And the DIB also saves time and money because they don't have to keep answering the same questions program after program after program. So that's really has been our approach to do it once and share it often.
So Alex mentioned talking and sharing with the utilities the information that he's acquired. There are ISACs and InfoGuards and such.
Independent and totally different. So totally different. We could, so they, I mean, it's not totally different. It's just like a different, it's like white wine and red wine. So the ISACs, or maybe it's like alcohol and liquor and wine. ISACs are usually dealing with vulnerabilities, whereas we're dealing with supply chain risks, right? Or for example, the risk could be, this product contains a chip, and that chip is coming from China, and we've detected a backdoor. EISACs would be more, hey, vulnerability. We've discovered a vulnerability on this piece of software, and it's installed on all the substations, and we've analyzed it, and it's exploitable under these conditions. So it's probably more like red wine or white wine. They're pretty similar, but the EISACs don't do what we do.
I guess I was being myopic when I started talking about threats. I was thinking of software vulnerabilities in particular, but there's also the product itself, and that gets factored in as well as a risk.
We're looking broadly, so I like to say threats with little t and vulnerabilities little v, because it's broadly, it's not specific CVEs, although those are included, and there are various types of threats. For example, one threat that everyone's having to deal with is foreign ownership, control, and influence. So, the challenge there is, other than a number of specific entities, you're allowed to buy product from China. But you have to understand that if and when you do so, there might be a risk of rip and replace. Like, I don't know if you heard about the Duke situation, where, they bought some batteries that were legal to buy, but they were a little risky because of where they came from. And those batteries were installed proximate to a military base. And so the military base asked Duke to rip and replace the batteries. So they were legal to buy and install, but there was a risk that their customer would object. So foreign ownership, control, and influence is kind of, compliance with that is kind of a threat that you have to be aware of, but it's very murky because it's not always clear what the exact requirement is.
I guess it's also not clear who you look into. Is the military base actively looking at their environs and determining that there are potential threats in these companies being so nearby?
In this case, they were, yeah. And actually, all the bases are now vetting their supply chains. The bases, the theory of the case is that, one theory is that the F-18 or the F-35 is very hard to hack. So the next best thing is to hack its supporting infrastructure. So if you can't fuel the F-18, it's just as good as shooting it down. So if you can hack the fuel pump, you can hack indirectly the F-18. Same thing with the ground-based radar. The GPS is probably the scariest one, but that's what the bases, the thought process, or the threat we're anticipating is that the adversary would hack the bases to slow our response and disrupt the mobilization of our troops and equipment.
So whose job is it to protect critical infrastructure?
Right now, the way it works is the private companies, there's nobody else owning it but them, so they need to step up and own it. So how can the government help? Should the government help them? I would say yes. And I think that's what CISA's job is, to help. It's the Critical Infrastructure Security Agency. So I think they're supposed to, I think I read their mission, just refreshing my memory this morning. It says they're supposed to help with risk identification and mitigation. So I think that's a good mission. So the question is, since we're talking about efficiency, are they doing it efficiently? So, I think that they've done, let's take SBOMs, for example, right? So they've made everyone aware what an SBOM is, but I think where they can be better and more efficient is to actually recognize that it's not about SBOMs, it's about quality software. SBOMs just tell you if the software is quality or not. So I think that one positive way to look at the disruption in our government is if we reduce spend, we can then reallocate that money to something more productive. So if we eliminate some of the redundant and arcane processes and technologies, we can reallocate that money into more innovative and useful areas, like figuring out how to secure that software. Let's take open source software, for example. We published a report that 90% of software in critical infrastructure contains a contribution from a Chinese national. So that's very scary. Now, everyone always asks me, well, did you find the smoking gun? And I always tell them, no, but what we did find is that no one's vetting that. No one's looking at that. We're the first ones to find that out. And we're not in the lab business. We just did that as part of our work helping customers. Here's the good news, and where this relates to CISA. I think 10 components account for 80% of the vulnerabilities. So if we just fix 10 components, we could wipe out 80% of the vulnerabilities. Remember, that's SBOMs. We're still in the SBOM. And so that might be an efficient use of government resources, government funding, to go out and fix those repositories, to hire some engineers to go secure those repositories, or even upgrade some of the libraries to the most current version.
So CISA has a list of known exploited vulnerabilities, KEVs, as opposed to looking at CVEs, which are just potential vulnerabilities that can be exploited.
That's a different topic, I think, but a very important one. I think the KEVs and also the drama around the National Vulnerability Database, that's impacting everyone's vulnerability management programs. Once your cybersecurity program reaches a certain level of sophistication or maturity, as we call it, you start to prioritize your vulnerabilities. And these prioritization approaches and methodologies and sometimes algorithms depend on NVD and the CISA KEV list to work. Like, let me be more clear about that for the non-technical people listening. If I have two vulnerabilities and I can only fix one, I'm going to fix the one that is most likely going to be used by an attacker. That's how I prioritize. And a lot goes into that. But a lot of what goes into that is the NVD and the CISA KEV. And so without those data points, I now am 50%, I'm just making that number up, but 50% less efficient. I'm less likely to guess which vulnerability is going to get exploited by the attacker. And as of yet, there has been no private sector participant willing to fill that void. Probably because, as an entrepreneur, my guess would be that they don't think there's no certainty that the government may not be back in that business tomorrow, right? It's a lack of predictability. So that's another inefficiency, because it's affecting prioritization and day-to-day security work. It's another inefficiency that our desire to create efficiency is creating.
I'd like to thank Alex for coming on the show and talking about the vulnerabilities in the supply chains affecting ICS systems. We're not doing enough right now to basically look at the pedigree of everything that's going into these critical infrastructures, and we probably should. Hey, if you're enjoying Error Code, tell a friend. I'm sure there are other people out there who like narrative information security podcasts. And I'd really like to hear from you. Go to errorcodepodcast.com to get more details. And tell me what you like and even what you don't. I've got some great episodes coming up. We'll have more on Volt Typhoon, Salt Typhoon, and hacking utilities supply chains. Subscribe today. I don't want you to miss out.